everyone, welcome to Chemistry. Today, day 12 class. Okay, in this video, I will discuss the conformation analysis in stereochemistry. Okay, please note, it's the most important topic in stereochemistry. Okay, listen. In conformation analysis, I'm going to discuss two important conformer. One is cyclohexane, and second one is butane. And finally, I will give summary about ethane. Okay. These three are very important our entrance exam point of view. Okay. Now we start from the cyclohexane. It's the most important compared to butane and ethane. Okay. Please note. Cyclohexane. Okay. Now what is the molecular formula? Molecular formula of cyclohexane, that is called C6H6. Okay. This okay, cyclic form. Okay. This exists as different form. One is chair form, other is boat form, okay, twist to boat, okay, and off chair. At room temperature. Okay, listen. For example, this is a chair form. Okay, this is a chair form. See, this is a chair form. This I will draw proper. Listen. 1, 2, 3, 4, 5, 6. You can draw this like. This is chair form. Okay. Now we're going to integrate boat form. Now see this interconversion. Okay, this is a chair form, right? This is a boat form. Now this is a twist boat. Okay, this is a twist boat. Okay. Now this interconversion can happen when, okay, whenever the carbon, please note the interconvertible by rotation of along carbon single bond, okay, single bond are called as conformational analysis. Please note, are called as conformation or rotational isomer, or rotational isomer. Okay. Listen, whenever the carbon single bond rotation will taken, okay, that is called conformational isomerism. Okay. Listen, carbon double bond, please note, is a restricted rotation. Okay. It means what? The carbon double bond rotation not take place. Okay. In case of single bond, we can easily rotate the carbon single bond. Therefore, the chair form is converted to boat form, and boat form converted to twist boat, and twist boat converted to the off chair. Okay. This can exist as a room temperature. Listen. Okay. For example, okay, you take one beaker. Okay, beaker. You put 20 ml of cyclohexane. Okay, in this beaker, what is actually the cyclohexane is a liquid form. Okay, but if you look the molecule, okay, you cannot see, right? But actually the molecule can exist for a different form, chair form, boat form, and twist boat off chair. Okay, what is the reason? They undergo the carbon the single bond rotation. That is called the conformational analysis or rotational isomerism. Okay, now. Okay, now I'm going to focus only the chair form. Okay, which is most stable form. Please note the most stable form. The chair form, note, very important. The chair form, the chair conformation is a most stable. It's a most stable form. Stable conformation of cyclohexane. Okay. What is the reason? Number one. Okay. Please note. Free angle strain. Okay. And second one, free from interaction. Okay. Because of these two reasons. Okay. Listen. In case of boat form, twist boat. Okay. the free angulation will be more in case of the half chair. Okay. Now note the stability order of the cyclohexane. Please note this very important exam point of view. Okay. Stability order. That is stability order. This is, please note, exam point of view. They will ask in our okay, MSc level entrance exam. Chair form, more stable. Then twist board, and next board form, and finally half chair. Okay, so I said the stability order of cyclohexane. Okay, which is more stable form. Please note the chair form is more stable. Okay, and half chair is for least stable. It's a stability order of the cyclohexane. Okay, now. Okay, I'm going to little bit advanced level. Okay, I'm going to the ring flipping as well as I will discuss the mono substituted cyclohexane. Okay, please note. Please note. What is ring flipping? Ring flipping. Listen, simple. Okay, during ring flipping. Okay, listen. Listen. Note. Before I enter this ring flipping, I will discuss about the axial equatorial bond. Okay, that one I have to need discuss, right? Now see this one. It's a cyclohexane, right? I can draw this like. See, in this cyclohexane, okay, this is one. Okay, now this is 2. Okay, 3 and 4 and 5 and 6. Okay, they are axial one. They are axial. This axial. Okay, this equatorial bond. This is a equatorial bond. This is a equatorial bond. Okay, therefore this is a equatorial bond. This is a equatorial bond. Okay, this is equatorial bond. This is equatorial bond. This is equatorial. Okay, if you look this axial bond, see in this axial bond, please understand. Okay, wait, I will change the color. See, this is up, right? This up. This also up. This also up. Okay, listen. 1, 2, 3, 4, 6. Okay, listen. Among 6 axial, the 3 axial bonds are up, right? Okay. What a down axial bond? 1, red color 1, 2, 3. Okay. But 3 axial bonds are down. Okay. Now see this carbon having axial bond up now. What are we going to down now? Similarly, okay. Similarly, in case of 6 equatorial bond, 6 equatorial, okay, and 3 equatorial is down, and 3 equatorial is what? Up. You got the point? Listen, okay. Now see, this is up axial, okay. Therefore, this down equatorial, okay. Now listen, this is what? This is a down axial, right? Therefore, this is up equatorial, okay. One carbon having 2 bonds, right? One is axial, other bond is equatorial, okay. One up axial, other one is what? Down equatorial, okay. In our cyclohexane, there are 2 different bonds. One is axial equatorial and 6 axial bond, 6 axial bond and 6 equatorial bond. Among 6 axial bond, 3 axial up, 3 axial down. Among this 6 equatorial bond and 3 equatorial bond up and 3 equatorial bond down. Okay, this is very important. Please note. Okay, now during ring flipping, what going to happen? Okay, please note. During ring flipping, please note. Ring flipping. Okay, the axial group is converted to equatorial group. Okay, for example, okay, I take this one. 1, 2, 3, 4, 5, 6. Okay, now I put methyl group here. Okay, now this is first carbon. Okay, let us assume first carbon. This is second carbon. This is third. This is 4. This is 5. This is 6. Okay, now if I do the ring flipping, okay, listen. 1 convert to 2, and 2 convert to 3, and 3 convert to 4, and 4 convert to 5, and 5 convert to 6, 6 convert to 1. Okay, now see this thing will happen. Okay, now listen. The one group, the methyl group, listen. In this structure, listen, wait. Sorry. In this structure, methyl group is axial, right? During ring flipping, okay, methyl become equatorial. This methyl become what? This methyl become equatorial. Okay, but during ring flipping, okay, the axial group convert to the equatorial position. Okay, this is very, very, very important. Okay, now we can try this one. Okay, you can try. I give you such a you can try. Tell me the position of group. Okay, now I put methyl group here. Okay, and Cl group here. Now do the ring flipping RF. Okay, ring flipping. Now tell me the position of methyl. It become equal to axial. Okay. Similarly, the position of Cl. Okay, listen. Now do ring flipping. Right? Very simple. See, it's a ring flipping, right? Okay. Now see this. Listen. We put 1 here, 1 and 2 and 3 and 4 and 5 and 6. Right. Now listen. Now this equatorial right become axial. You got the point? Axial. This axial become equatorial. This structure. Okay. After this axial become equatorial, right? This equatorial become axial. Okay. Now this is test yourself question. You can try this question and tell me answer in comment section. Okay. You can just try. Do the ring flipping and tell me the position. Okay. Here Cl. Here also one Cl. Here also Ethane. Do ring flipping and draw the structure. Okay. Ring flipping. You try this one. Okay, this is what this is a common structure. Okay, now listen. Now what is the next question? Okay, now say what does the next question mean? In first structure, the ME group is axial, right? And the ME group is equatorial. Second, okay, structure 1 is structure 2. Among this structure, which is the most stable? Okay, now I'm going to try to find out among this. Suppose the methyl group occupy the axial, or equatorial, which is more preference to occupy the methyl preference to the occupy. Okay, either axial or equatorial. I'm going to discuss now. Please come. That is called the mono substituted cyclohexane. That is very, very important exam item. Please. Next topic. The mono substituted. Listen, in case of CSL, all get the exam level. Okay, they will ask a di-substituted, tri-substituted also. Okay, in our CUC, even IIT JAM also they will ask. Okay, in case of C with the exam level, the mono substituted is enough. Mono substituted cyclohexane. Okay, see. Now I take this. Okay, I take this normal structure. This is methyl. It's a methyl cyclohexane. This is formula. So I use that name. It's a methyl cyclohexane. Okay. Now listen. This molecule actually not be this like structure. Okay. They exist as char form, right? Because char form is the most stable form of the cyclohexane. Okay. Now write the char form. It's a char form. Okay. Now I put methyl group here. Carbon, hydrogen, and nitrogen. Okay. Now I do the ring flipping. Okay. Now methyl group become this side. Now this is methyl group. Hydrogen. Okay. This is structure 1. This is structure 2. Okay. Listen. In this structure, what does stability order mean? The second is more stable compared to 1. Why? What is the reason? See, in this first structure, okay, the methyl group, what is the position of methyl group? Axial equatorial is axial bond, right? This is equatorial bond. Listen, in this structure 1, listen, please understand, this is 1, this is 2, this is 3, right? They are having hydrogen atom, right? Therefore, this becomes one hydrogen atom. Here, hydrogen axial. You got the point? This is 1, 2, 3. Similarly, this 1, this also 2, this also 3, right? This is axial bond. Now, see, in this case, listen, now this methyl group, please note. Now this methyl group going to interact with this hydrogen, okay, because both this is very near to the methyl group, right? Therefore, this hydrogen, axial hydrogen, okay, going to interact with this methyl group. That is called steric hindrance. Okay. Similarly, this HA, okay, this hydrogen axial group going to interact with this methyl group. Therefore, this is 1, this is 2, this is 3, right? But this also axial, right? Methyl group. This also axial. Therefore, this 1,3 diaxial interaction. Please note, very, very important. In structure 1, okay, in structure 1, the 1,3 diaxial interaction will take place. How many 1,3 diaxial interaction? It can be. This is 1. This is 2. Therefore, the 2. Please note, they are the 2. 1,3 and diaxial interaction. Okay. Now, see, in this case, tell me, in this case, okay, this is equatorial bond, right? Equatorial bond. Okay. Now, I put hydrogen here. This is here. This, okay. This one. This is a above the plane, is below the plane, right? There is no interaction. Similarly, this hydrogen. Okay. Similarly, this hydrogen. There is no interaction. Okay. But whenever the methyl group is equatorial position, no no 1,3 diaxial interaction. Listen, whenever the interaction will happen, okay, the molecule become least stable. Therefore, in structure 2, they have two 1,3 diaxial interaction. In structure 1, the no 1,3 diaxial interaction. Therefore, the structure 2 is more stable, always structure 1. Okay. Whenever the bulky group to prefer which position? People always the equatorial position. Okay, very, very important. Please note. Okay, please note. Okay, please note. Very, very important. Okay. The bulky group. Bulky to prefer occupy, okay, equatorial position, okay. Now this is okay, I'm going to explain based on the conformational free energy value, okay. This is a little bit advanced topic, but most important, please note the conformation free energy, that is called A value, okay. Now A value going is experimental, okay, this experiment, okay. The A value going to tell, okay, which group going to occupy equatorial position, okay, is favored compared to axial position, okay. Please note, it is a concept. The free energy delta G, okay. The free energy difference between axial and equatorial substitution in cyclohexane is called the conformational free energy. Conformation free energy. What is the symbol? That is A. Okay. Next point, please note. Very important. Higher the value of conformational free energy, higher the value of conformation free energy, okay, of the substitution of the substituent, more will be preference for equatorial position, okay. Therefore, higher the A value, okay, that group going to occupy always what? The equatorial position, okay. Now see, I give you some example, very, very important, okay. Now take X group, okay. This is A value. This is a percentage of equatorial conformer, okay. Now I put hydrogen. Okay, I use different colors. I put hydrogen. The A value is 0. Therefore, okay. Therefore, what? The 50% chance for what? Occupy the equatorial, okay. Therefore, methyl group. What is A value? 7.5. Therefore, 95%. Please note. Then ethyl group. What is A value? 8.10. Therefore, this is 96%. Okay. Next step. Group. Isopropyl, very important. Isopropyl group. What is A value? 9.0. What is percentage? 98%. Okay. Therefore, tertiary butyl. Okay. What is A value? 20. What is the percentage? 99.9%. Okay. Now OME group. Please understand. Okay. What is the A value? 2.51. That is 73%. Okay. Listen, these 5 are very okay. This is 1, 2, 3, 4, 5, 6. This 6 value very important. Okay. Which is more bulky group? Tertiary butyl. Okay. What is percentage of equatorial? This is 99.9%. Okay. Listen. Now this in this table, what we are going to discuss about now? So methyl and OME. See, the methyl having more A value compared to OME. Okay. Therefore, if going to methyl and OME, listen. For example, 2 group or 2 methyl are equatorial. Okay. Now with 2 methyl equatorial is highly favored, right? But OME group, so OME group have the value of A value. So 2.51, it means what? The OME can prefer the axial portion over the equatorial portion compared to methyl. Okay, listen. Actually, OME is in equatorial portion is more stable compared to axial. Okay, any bulky group at the equatorial portion is more stable. We're going to compare to methyl and OME, which is a more A value methyl group, right? It means what? The methyl is prefers the equatorial portion as compared to OME group. Okay, this is a very important one. Please note it. Okay, the exam point of view, they will ask a question based on this concept. Okay, this is the most important. Okay, now. Okay. This is about what? This is about the cyclohexane. Okay, listen. They will ask the stability order, or they will ask. They give you the listen. The cyclohexane concept. They'll L2 the problem for the reagent concept. Okay, they do the problem. They give the cyclohexane structure. You have to put the substitution either downside upside. Okay, based on that reaction, the epoxy formation reaction. Okay, the stereochemistry cyclohexane is very important. Okay, in our CET PG exam, this much is enough. Okay. Now, so I go with next. I go with enter to the butane. It's very important. Please note butane. Let's see. Now carbon. Right. Now this is hydrogen. This is hydrogen. This hydrogen. Similarly, this hydrogen, and this hydrogen, and this hydrogen, this hydrogen, and this hydrogen. Right, okay, this is a butane, right? See, now I'm going to draw this butane as our Newman projection. Okay, now see, very simple. Now I'm going to draw this line for butane. See, here CH3. This is also butane, right? Here hydrogen, here hydrogen, here also hydrogen, here hydrogen, CH3. This is also butane. Okay. Now see, this is a first carbon. This is first carbon. This is second carbon. Okay. Now I'm going to convert to Newman. Okay, listen. Already I discussed the conversion. Okay, how to convert Newman to Saga to Fisher. I already discussed. I have one playlist in YouTube channel. Okay, go and check the stereochemistry playlist. That playlist I discussed already. Conformation of cyclohexane. Sorry, I discussed already what the Newman projection, Sagas projection. Okay, how to convert a Newman to Sagas. That part I already discussed. I'm going to discuss directly to the concept. Okay, now see, now going to draw the structure of of the butane. Please note, this is the first form. This is a Newman projection, right? Newman projection. Now this is CH3. This is hydrogen. This hydrogen. Okay, this dot is carbon, circle is carbon. You know, right? Now this is CH3. This is H. This is H. This is called staggered form because listen. Two methyl group. Listen, this two methyl group. Okay, at 180 degree. Okay, this staggered form. Please note. This is a staggered form. Staggered. Okay. Now I do the 60 degree rotation. So very simple. Okay, listen. Circle of fix paniko. Okay, you're going to rotate this one. Okay? Either you have to fix one carbon atom and do the rotation. Okay. This one. Okay? Now I do rotation of circle atom. Okay. Now see, this is a fixed one. Here CH3. Here hydrogen. Here hydrogen. Now do the rotation. Now see, this CH3 become here, right? This is CH3. This is H. This is H. This form, okay? Again, do other 60 degree. Similar. This is CH3. This is H. And this H, okay? Now this H become here, right? Come. This CH3 become here. Now, therefore, this is H, this is CH3, okay, this is H. Again, do 60 degree. Okay. 1, 2, 3. This CH3. This become backside of this CH3. This hydrogen is a backside. This hydrogen is a backside. See. Now, this conformal stagger, right? This is called, listen, when two methyl group at 0 degree, 0 angle, okay, this is called eclipse. This is called fully eclipse. You call fully eclipse. Why I tell fully eclipse? Just wait, okay? Fully eclipse. Okay. Now see. Now CH3HR again 0 degree. This is a person. Now CH3 bulky group. H is small group, right? Now this two CH3 both are bulky group. Therefore, this fully eclipse. This is a partial eclipse. It's a partially eclipse. Now see. Now two CH3 group. Okay, at angle of 60 degree, they call gouge form, or some people call skew form. Okay, therefore the cyclohexane can exist how many forms? Staggered, partial, skew, and fully eclipse. Okay, actually answer is 4, but listen, please understand. Okay, and in another confirmation, they will change what? They will change the infinite number of. Okay, listen, infinite number of the conformer can possible. Okay, in exam they will ask how many conformer of cyclohexane can possible of butane get. The answer is infinite, because you can change the room temperature, you can change at the room temperature. You convert to stagger, convert to eclipse, and eclipse convert to Gauge form, and Gauge form fully eclipse again. The rotation will take place. They convert to what? They show the infinite isomer. Okay, suppose they will give they don't give the infinite in the option. Then what is the conformer answer? Staggered, a partial eclipse, skew, a partial full eclipse. Answer is 4. Okay, suppose answer now in the 4 option they give infinite. Now the answer is infinite. Okay, a simple question will be there. Okay, how many conformer for ethane? Okay, some people call answer 2. Why 2? Now staggered eclipse. Actually the answer is infinite, because not stagger convert eclipse. They will convert room temperature. They will exist. They will change. They undergo carbon rotation, continuously change. They will in the option the infinite will be infinite is given now. That is answer. Suppose the infinite is not given. Okay, in case of in case of butane, staggered, partial eclipse, Gauge form, and full eclipse. Therefore, answer is 4. Okay, how many conformer possible? How many conformer possible? Answer is 4. Okay, so, but actually, what is actual answer? Infinite. That is infinite answer. Please, very important. Okay, now see. What is the stability order? What is the stability order? Please note. Okay, staggered form more stable, then skew form, then partially eclipse, and finally fully eclipse. Okay, this is actual order. This is very important. Okay. Suppose, okay, now 1,2, okay, 1,2 ethane diol. Okay, that's very interesting, very important. Please note. Okay, just wait. 1,2 ethane diol. This also like a butane. Okay, because instead of 2 methyl group, 2 OH will be there. Okay, now see, carbon, hydrogen, and OH. Okay, this also can exist 4 form. Okay, on a staggered and partial eclipse and Gauge or skew. Okay, full eclipse. Okay, they can exist a 4 form. But in this structure, okay, which is more stable? Now please note. Okay, stability order. No, I will draw 2 structure. Okay, extreme structure. Okay, listen. One is staggered form. Here OH, here also OH, here H, this is H, and this H. This okay. This is staggered form. Staggered form. Now I go and try the skew form. That is called Gauge form. Here CH, sorry, OH. Here also OH. Here H. Here H. Here H. Here. Okay. This is a Gauge form. Now, which is more stable? The staggered is more stable. Why staggered is more stable? And 2 OH come away from each other. In this 2 OH is 60 degree, right? Now, which is the most stable? Staggered. But actually, answer is a Gauge form is the most stable. What is the reason now? You listen. Now, what is the degree of this OH is 60 degree, right? Listen. Now, this 60 degree, this OH bond, hydrogen atom, going to hydrogen with other oxygen atom. Okay. But in this Gauge form, when 2 OH group at the 60 degree, they will possible of hydrogen bonding. Okay. Because of this hydrogen bonding, please note the Gauge form are more stable as compared to staggered. Remaining all same now. Staggered form. Adukappuram paathana partial eclipse, adukappuram full eclipse. Okay. This is very important. Please note. Okay. This is very important. Please note. Okay. Similarly, 1,2 ethane. Okay, for as a dichloroethane and dibromoethane, that case I will discuss. Okay, now please note, very important, please note. Suppose they give this lecture, note, very important. Carbon, hydrogen, here OH, in hydrogen, this hydrogen, in X. Now see, X can be OH, X can be fluorine, X can be nitrogen. In this case, always what? The Gauge form is more stable over the staggered form. Okay, very important. Okay, and first one. And second case, please. Similarly, here carbon, here hydrogen, here hydrogen, here XA. Okay, two carbon. Listen, X can be fluorine. Okay, X can be fluorine. Now, fluorine is small group. Fluorine is a small group, therefore they form hydrogen bond. The Gauge form more stable compared to staggered form. Okay, suppose the 2X group can be And ClBr iodine mean is a bulky group. In this case, what? Bulky group. In this case, the staggered form is more stable compared to gauge form. Okay, this is a very important. Please note. Okay, 1,2 ethane diol, the gauge form is more stable as compared to the staggered form. Okay, and butane staggered is more compared to gauge form. Adhe on the OH kuda any other substitution will be given. They form hydrogen bonding. Now that is gauge form is more stable. Okay, suppose the molecule given the 2x, two different 2x mean. Okay, X can be fluorine. Now the fluorine is small group. They will bond with the hydrogen bond with the neighboring hydrogen atom with after 60 degree. That case gauge form more stable. Other in case of halogen can be chlorine, bromine, iodine mean is a bulky group. Okay, it's a bulky group. They also form hydrogen bond. Okay, compared to hydrogen bond, due to the compared to hydrogen bond, they undergo the repulsion. Okay, the repulsion over the hydrogen bond. Therefore, in that case, chlorine, bromine, iodine, due to bulky group, the staggered is most compared to what? Compared to the ski form or gauge form. Okay, this is very important. Okay, this is about the today class. Okay, listen. In the exam point of view, they will ask surely a question based on cyclohexane or butane. Okay, and ethane we know, right? Ethane can exist two different forms. One is staggered, one is eclipse. Okay, it's very simple. I hope understand. Okay, I will upload the assignment and